Awesome. Thanks so much, John. And welcome to my webinar. As John said, it's called Kubernetes Delivery Unlocked. And a little bit about me. So I'm Liam. I've been with Octopus for about 3 years. But before that, I was a Kubernetes expert leading a platform team at another software company here in Brisbane. While I was there, we had about 50 clusters, not including our dev clusters. And even before that, I was a Linux systems engineer working with Red Hat Enterprise Linux and doing all of these kinds of things like delivery pipelines in a more classic systems administrator way. While I've been at Octopus, I've actually kind of been around the bush a little bit. So first, I was at a team called Engineering Productivity, and this is an internal team that works with Kubernetes to build a platform, specifically for our build infrastructure. Then I moved to Cloud Platform, which is another platform team dedicated to hosting Octopus for our customers in the cloud. That also runs in Kubernetes for what it's worth. And then I moved to Modern Deployment, where I just do development work again, which has been a great change of pace. But I'm building software to make deploying to Kubernetes better now. So still working with Kubernetes, just a little bit differently. So over the last 5 to 10 years, I've kind of transitioned from somebody that's been a practitioner of Kubernetes to somebody that's developing on Kubernetes for Kubernetes. So a part of that is that I've learned quite a bit over my time, both building for Kubernetes and on top of Kubernetes. So I put all of that into the white paper that John mentioned before, Kubernetes Delivery Unlocked. What I'll go through today is a little bit of that information. So the basics, mapping your process, imagining your pipeline was a factory floor, how can you make it better, that kind of thing. The strategies that you might use, the different types of tools, your deployment methodologies, things like progressive delivery. There should be time for questions. Feel free to put them into the chat. I can answer them at the end. Just put them in any time. So before we get too far in, Kubernetes is quite complex. So let's start with a baseline. What on earth is Kubernetes? A lot of people will say that it's an orchestrator, but I'm a developer. I like calling it an API. A normal API is a way to connect between a couple of systems. Kubernetes, it lets you do that with your infrastructure. It lets you manage your compute capacity, things like nodes that might be in the cloud, but they can be on premises too. Lets you manage infrastructure concerns like disks, your quotas, your networking. And then it lets you manage your workloads themselves by using binaries and containers and configuration like config maps and secrets. But how does it run? Now, I'm going to go into it a little bit, but it's going to be an oversimplification. The Kubernetes Docs team is incredible. I've worked with them before. They do amazing work. Have a look at the Kubernetes website if you're curious. They've got so many examples on how various things work. So what you do is you go and ask Kubernetes to run a pod. It's the smallest unit of work that you can define in Kubernetes. Now, you can define a pod in a lot of different ways, but let's just ignore that. The pod really is just an instance of your application. It'll include things like the configuration, the secrets, the binaries, and the environment that it runs in. It lets you essentially abstract away all of the other things like networking and volumes. That's all Kubernetes' job. Now, when you think of Kubernetes as an API, it's simple, right? All you're doing is asking an API to create infrastructure for you. But how does that apply to CD, right? Because it may be easy to say, oh, it's just an API. But what do you actually need to do when it comes to delivery? Now, note that I do like putting little GIFs on my slides, so sorry about that. Now, no matter who you ask about CD, there's going to be different opinions. Some people will say that CD is continuous delivery. Some people will say it's continuous deployment. Some people say that these things are actually different and there are distinctions, like whether there's a human involved in the process or whether every artifact is immediately deployed to production. I tend to take a different stance where I don't think it really matters what it's called, continuous delivery or deployment. I think that CD is just shipping software efficiently. Now, why should you care? Why should you invest in this? Because it is an investment. Now, the more software you write, the harder it is to deploy manually. Humans slow you down with that. Nobody likes doing a manual process where you've got to tick every box, and that's something that you do have to do when you're deploying to production. Developers will wait longer to ship because they don't like doing the process, which, let's face it, like I didn't. And when you do that, customers wait longer for software. Then, because you've waited longer, you get more bugs. Batches are changed. Changes are batched up. They're really hard to test because everything is all together. And then it takes longer to fix them because, again, it takes longer to ship. And as you break things, you find that developers just don't remember the code that broke. Because I barely remember what I had for breakfast yesterday. So, you know. So without even getting into Kubernetes, there are 4 best practices. These have been discovered over years of trial and error as we built more complex systems in continuous deployment. The first, always be ready to deploy to production. You don't always need your latest code in production, but you should be confident that it won't break if you put it there. You can do this by using feature toggles to prevent prevent new features being run. And you can make sure that your new code doesn't break things by automatically deploying to temporary environments. Kubernetes can help with that for what it's worth. And that also helps developers to have a much shorter feedback loop. Now, real quick story time. This is based on a real experience I had in my career. So imagine, just for a second, you're a young systems engineer. You get an alert that the database is out of memory. Uh-oh. But we are smart. We have an option to let the database use a read replica. That lets us reduce the load. That's great. Oh, why can't I deploy my new config? About an hour of troubleshooting later, I found out. This young systems engineer found out that we needed a new MQ disk mounted on the root. That was for our messaging queue. There was a feature that was in the middle of being rolled out that needed infrastructure to be there first. It didn't help that the logs were non-existent because they didn't expect it to be used. But when I look back on this experience, I realized that, we weren't following that golden rule, that first golden rule. We weren't making sure that we could deploy. So when I tried, it failed. And it'll happen to everybody here, probably. So there's a few ways that Kubernetes would have been able to help with this. The first thing is we could have defined those new disk requirements in code. So when I deployed my change to update the database, it also got the new disk. That would have been awesome. Or we could have deployed to temporary environments in shared clusters. That lets us make sure that it'll still work for prod, even if we're not actually deploying there. If you look back in your early days of your career, is there anything that you can see that happened that you weren't following the golden rule and just completely broke on you? Because I've got a lot more of these stories. The golden rule number 2 is to build once and deploy everywhere. Who here has deployed and immediately gotten a call from somebody higher up saying that something looked wrong or something wasn't working? It's not a fun call. Don't be this surprised Pikachu. Mitigate it by building once and deploying everywhere. Rather than having bespoke builds for each customer. Oh, it's never happened, Jordan. That's cool. I am very jealous. It's definitely happened to me. But yeah, rather than having bespoke builds for every customer. Yes, I see, Jordan. I am very jealous. I'm certain that it works the first time as well. But yeah, rather than using the bespoke builds for every customer, you use the same build and just vary your configuration. When you're using Kubernetes, Use containers. It lets you have all of your dependencies, all your runtimes all bundled together. There's been a few times where I've deployed something specifically with PHP. I don't want to talk about it. Please don't hurt me. But when I was using PHP and we had a very slightly different of PHP FPM installed, and that very slight difference made just a whole bunch of things break in just weird and wonderful ways. Containers would have fixed that for me. I didn't know it at the time, but it would have been so much nicer. Then use mutable tags for those containers. They're essentially tags that don't change. It lets you be certain that when you're running something in pre-prod, you've had a look at it, made sure it works. It's the same as what's running in production. Golden rule number 3 is to include everything, all of your components. You don't usually deploy your app in isolation. You'll often need things like file systems, load balancers, databases. Again, if you don't, I'm really jealous. So, yeah, these are just really hard to deal with. Dependencies are some of the hardest things to work around in your code because you can't always figure out exactly how they're going to react. Not only do you need to think of the initial state of these dependencies, but you also need to figure out what happens when you change them. And part of that is you also need to test how the change works, right? The only way to effectively test every change is to automate it. Automating testing of infrastructure is way easier when you just define it as YAML and let Kubernetes do it all. So Kubernetes just lets you define everything as code. Your disk, your network, your load balancing, your databases. You can use things like controllers, that's essentially software that runs software in Kubernetes. Think of it as, a piece of software that runs a database for you. Really, really useful. Or you can use something like Crossplane, which lets you go through and in Kubernetes define a cloud database, and it'll bring it up in the cloud for you. Whether it's Azure or AWS or Google Cloud or Alibaba Cloud, who knows? But that lets you just test all of the things. The last golden rule is deploy to test the same way that you deploy to production. Works on my machine, doesn't usually cut it when you say it to customers. I've tried. Would you deploy your code to prod without any testing? If you wouldn't, you probably shouldn't use CD for just prod either. When you use Kubernetes, you can use the same tools and abstractions for dev, testing, staging, and production. Kubernetes doesn't really care whether it's in the cloud or in the rack. It'll act the same. That means you can exercise your CD pipeline way more often, which makes you way more confident that it'll work when you need it the most. Hopefully you're convinced that CD is a good thing by now. Maybe even that Kubernetes can help. But where should it go? What even is our process? I promise I don't have an MBA, but let's get to mapping our process. Before you jump in to actually ripping everything apart, it's worth having a little think, just like Homer is here. What environments do you have? Do you have dev, prod, staging? What are they there for? What's the configuration that you've got? How might it change in the future? What is different in between your environments? Is any of it secret? Have you got any dependencies like databases, storage, network, like we were talking before? Then you start mapping. I'm such an incredible artist, so I've just taken the time to give you a real life view of something that I was mapping for an app that I was building. It makes sense to me at the time. I know it looks a little bit dodgy. Trust me, it works. Nobody's going to look at it again. It's documentation. My process was to go to dev and then production. I was building straight from Team City, which is why TC is there. And for each environment, I had a Slack token, some blob storage, a database, and a target channel that I was going to post to with Slack. The next step that you take is you note down where you need to check something. in any deployment process, in any kind of process at all, you'll have steps where you'll be doing QA, quality assurance. You can have a fancy camera automated system that rejects things when they aren't right. Imagine, you're going through and checking apples and you're looking for ones with bruises and you're puffing them out with a burst of air. That's essentially your automated unit and end-to-end tests. Sometimes they can be hard to set up. It's a big machine and it can be hard to tune and it can be expensive, but it's incredibly efficient and it lets you go through and make sure every apple, every single release goes through this process. You can also have at the end of that humans that check, right? They can apply logic and reasoning. They can recognize patterns. They're also really expensive, but they don't kind of make up for it by checking every single thing. They can miss things. So what you do is you map out points where humans will check where something might go wrong. That can also lead to things like approval, where you don't ship to something without it being ready, right? You don't ship to prod unless you're certain that it's all good. For this one, I just added some tests in TeamCity just to make sure that everything was working. You could do this in GitHub Actions as well. It's the exact same thing. And then just a sanity check manual approval before production. The next thing you got to do is document your limitations. You've got to consider what your software does, how it runs, whether you can run multiple copies, what you need to do when you change your schema, what happens when you change your file system. Consider that with your dependencies as well. Do you need every single replica to have access to the file system concurrently? If so, you can't just plug a USB drive into it, right? You need to have something like networked file storage, that kind of thing. So it's really worth considering your dependencies here. Now, the final map for me, again, this is a real map that I made to kind of explain what I needed to do in one of the applications I was building. So we had automated tests there in TeamCity. We had a dev, a staging, and a prod environment. We've got those sketchy eyes there saying that QA is going to look at the staging one and approve it before it goes to prod. In there, we have our dependencies that we were talking about before, the secret Slack token, a couple of bits of storage like Postgres and Azure Blobs for storage, and a target channel, which is just a variable. The touch points here was just the test on build, validating that dev deployed successfully to Kubernetes, the deploy to staging, and the QA check and approval to go to prod. Some of the limitations we had was that storage needed to be consistent for each replica, because we would store something in the database as like essentially a file path and then would pull it back out to try and push it to Slack, and it needed to be there. The database also needed to be pretty quick, just because we were dealing with real-time communication, and we needed the schema to be compatible if we were running multiple versions. If your process and environment is the map, then your deployment tooling is the car. It lets you follow the map. There's a few different ways that you can deal with this. You can deal with it with GitOps. It's a really cool deployment tool. It's one of the most popular methods of deploying to Kubernetes. There are tools to implement GitOps fundamentals like Argo CD, CodeFresh, and they've made deploying to Kubernetes really smooth. Kubernetes lets you declare your infrastructure as code. Just like any code, the benefit of that is that you can just pop it in Git. It's something that all developers know how to do, really. Unless you work at, I believe it's Meta, which decided to use Git in a very weird and wonderful way. If you need to make a change to your infrastructure, you just commit the change to Git. You can use PRs as a way to gate progression. And since everything is stored in Git, you get all of the benefits of that. You get things like auditability. You know exactly who went and changed something and when. You get consistency. You know that when you've committed something, that's what's in production, right? There's no ifs, whens, or buts. There's no failed deployments. That's what's running. You also get all of your existing workflows around it. You might have little Slack notifications when you make a PR. All of that you kind of just get for free with GitOps. You also get a couple of challenges though, specifically the learning curve. I've worked with GitOps before, and there are still parts of it that scare me. Um, it's really complicated in some cases. Um, you've got other challenges like secrets and how you handle them. It can be a really complicated problem to solve, especially if you need to update them frequently. And then if you've got a lot of environments, the config sprawl can be really bad. You can have so many different repositories with all of this different config. You've got to map them in between them, and it can be really painful. If you've got a simple app like the app that I was showing you before, it's really easy to model in Git with repositories. But if you've got a complex map that looks a little bit more like the map of London rather than this, it can be a lot more complex to deal with. Pipelines, on the other hand, are really flexible. Even if you're not using a pipeline-based CD tool like Octopus, you're probably using some kind of pipeline tool, something like GitHub Actions or Jenkins or TeamCity. Pipelines just let you define logical steps to deploy your software to any environment. It's useful for infrastructure outside of Kubernetes as well as inside Kubernetes. Things like if you've got AWS Lambdas or any serverless functions, that kind of stuff can be really easily deployed with a pipeline-based tool. If you've got things like databases, you can do that with pipeline-based tools without having to work with cross-plane or controllers. If you've got things like other cloud services that you need to connect to inside your deployment process, that can be really useful to deal with inside of a pipeline tool. It lets you define things like approvals and alerts, and the best pipeline tools that are built for CD, like Octopus, are really powerful. They have things like environments, tenants, and secrets as first-class citizens, first-class concepts. Lets you get started really easily because the tool takes away a lot of the complexity of environments and tenants and promotions and all of that, and gives you an actual way to just move forward. You just put in your map and it takes care of the rest. Once you've chosen your car, the rubber hits the road. You can decide how to actually deploy your application. Now, the first thing is just all at once. You may notice the lack of a GIF or GIF, it's up to you. I tried to put one in, but the service didn't respond because it was in the middle of a deployment. If you're restricted by your software or a dependency that stops you from running different versions of your application at once, you may need to just do an all-at-once deployment. Customers will likely experience an outage, and then your app just comes back with the new version. If you can run multiple versions, there are better ways. First, canaries. Like the old story of canaries and mines, you can put a small amount of traffic that's coming into your infrastructure and just send it to a new version. Then you monitor that traffic. You just make sure that anything that's going to that new version is coming back fine. You monitor error rates, you monitor response time, anything you can. And then over time, you bump up all of your traffic until just the new version is used. Bugs are found really quickly because, as we are all aware, the plan is perfect until you get punched in the face. The deployment is perfect until it hits the users. So you find issues real quick. You can also send traffic to the old version if you have problems. You can just go, oh, something bad is happening. Just roll back immediately. The next thing you can do is blue-green. You create a new version. It's usually called the green version. You use the same database, so you do need to make sure that it's interoperable. Then you test the environment. You can do this manually just by connecting to the new environment. Some people just put green dot in front of the domain name to just go and test it out. Or you can even do things automatically by doing, mirroring traffic directly from blue to green, and then making sure that you're responding with the correct information and in the correct times. You use this as well to warm up the green environment. It means that you can essentially have all of your caches all warmed up prior to actual customer traffic hitting it. And then all at once, you swap the traffic. And that's your deployment. Your customer traffic doesn't hit green until it's been tested and warmed up. It means that they don't get any different versions of your software. You don't click a button and see something, and then when you do that again, it goes away. It's really useful for things like features. Either this or Canary deployments can help your app keep serving customers while you roll out new versions. And that's a really good way of making sure that I can put GIFs in my presentations. So what's next? This really is just the tip of the iceberg. There's so much more to learn about CD and Kubernetes. The white paper, which you can get by scanning that QR code for free, by the way, for free. It's got a whole bunch of information to help guide you through deploying your applications to Kubernetes. There's tons of information about what secrets are, what config maps are, and how you're able to go through and use them in your deployment processes, and how to use GitOps and pipeline tools to get all of this stuff working. Thanks for listening to me rant about continuous deployment for a while. Questions are more than welcome. I see that we've got a couple already, which is really cool. So I can run through them if you'd like, John.
Sure. Yeah, let's go ahead and do that. So the first question we have here is from, excuse me, I'm very emotional. I really loved what you were saying. Sorry, got a bit of a cold. So Santosh writes, what would be a better approach for DB deployment specific to PostgreSDB on Kubernetes with operator basis, Helm, or customization? Which one is better? So for folks who don't know, you have a few tools at your disposal here in use with Kubernetes. So you have Helm, which is at helm.sh. This is a way of actually being able to deploy applications similar to what you would do with NPM, for example. In a similar sense, that's one option. The other one is Customize, which is what I believe Santosh is mentioning. So Customize, which at customize.io, allows you to do variable replacement within your config scripts for Kubernetes. So on the topic of database deployments here, Liam, what would you say to Santosh?
Yeah. So in terms of which one is better, both are simply tools. You can't really say whether a hammer is better than a saw. It depends on how you're using it and what you're using it for, and what everybody else in your company knows how to use. If everybody in your company knows how to use Helm and nobody knows how to use Customize, I can guarantee you Helm is going to be the better choice. But Inversely, if everybody knows Customize, then Customize is going to be the better choice. There is no innate benefit between the two. Helm tends to be slightly more flexible. You can do things like pre-install hooks for that kind of thing, but a lot of that isn't really useful when it comes to operators. So take this with a grain of salt. Helm, slightly more complex, but gives you a lot more room to move around should you need to do something a little bit different than the established patterns, right? You might need to install your database and then have in that same chart, you might also want to go through and bump your app version immediately afterwards. That's possible with Helm, but with Customize, it's a little bit more difficult. So in general, I tend to choose Helm. Probably helps that I've contributed a little bit of code to Helm, so I understand it a little bit more than I do Customize. But that's pretty much my kind of opinion.
Interesting side note, we actually have a Helm chart for Octopus. So if you're looking to run Octopus on a Kubernetes cluster, you can use our Helm chart, which is available online. Also, we do have the ability of running Customize as part of a deployment process or runbook as well. So if you're looking at doing that in conjunction with Octopus, gives you that option.
Octopus works with both Customize and Helm. We have options for both. They're both supported as first-class citizens.
Yeah, awesome. Good question here from Jordan. Is there any way to redirect certain types of traffic to the quote Canary version? Like if we have users accessing a.site.com, b.site.com, or c.site.com, can we redirect all traffic for the A and B subdomains? Now, I'm guessing that this is largely in the context of Kubernetes. Obviously, it gets even more gnarly because I immediately gravitated to the old '90s approach of load balancers, right? So, but here it's getting a little bit gnarly in terms of pods and obviously where your sites are running.
Yeah, I mean the answer classically, it's still load balancers, but really fancy load balancers. So it's really cool in Kubernetes because you can abstract away all of the networking. There are tools called service meshes, and these allow you to go through and dynamically route your traffic to various endpoints based on the host that comes in. You don't even technically need to use it for this specific example. For example, if somebody's visiting a.site.com, you can redirect that to a different service in the backend in Kubernetes quite easily using either ingresses or the new gateway API that's coming through Kubernetes now. So you can do that stock standard. But when it comes to canarying, rather than trying to get users to access a.site.com or b.site.com, you just access site.com. And then what you can do is with the service mesh, you can deterministically put 5% of your traffic to the new version internally. And you can do that with things like Kong or Istio, which are both service meshes. And then you can use progressive delivery controllers like Argo rollouts, which is probably the best in class at the moment, to control that automatically for you and control automatic rollbacks. So the best way to deal with it in Kubernetes is to kind of build a classic deck of cards where, or a house of cards where you've got at the base here, you've got Argo rollouts, you've got your service mesh like Istio. And as you roll your changes out, though that base goes through and controls that routing for you. So, rollouts, the very top menu, the third one there.
Oh yeah.
There we go.
I'm just showing the website here. Most people don't know that they're I wouldn't. That's unfair. Most people equate Argo to Argo CD, but it does have other capabilities such as workflows, rollouts, events. So there's Argo rollouts. You want to read more about that?
Yeah, Argo rollouts, you don't need Argo deploy to use. Argo rollouts is a completely separate project with the same name, and you can use it with anything. You don't even need to really have any CD pipeline to use Argo rollouts, though it's definitely recommended that you do because for all the reasons I mentioned before.
Awesome. All right, so we have another question here from Vincent who asks, what if you have your nodes set to a number that rarely changes? How do you handle a blue-green deployment if those additional pods can't be scheduled?
That's a really good question. And at that point, I'd kind of probably would blue-green deployment be the right tool for you then? Again, blue-green and canary, they're tools. And you use the one that suits you the most. If you have very little in the way of spare compute, then blue-green deployments probably aren't going to work for you. But then I'd also ask you another question in that, what happens if you suddenly get double the amount of users tomorrow? Are your servers going to fall over because you don't have enough compute capacity? The whole point of Kubernetes is to allow things like dynamic scaling. It lets you go and add more as you get more users to come in. It lets you do it where you don't have to pay for them all the time, only when you need them. And that's where it can be really useful here as well, where if you're running in a cloud provider, for example, you can use things like node auto scaling, where if you have more pods coming in because you're doing a deployment or because you're having more users visit your app, you can go through and add those nodes temporarily and just go through and pre-warm everything and get all of your users to be served without degradation.
Awesome. All right. This is us tap dancing here. I'll let Liam recover while we're waiting for other questions. Just to remind folks, if you have any questions about what we're showing here, you can check out our website. This is available at octopus.com. The website you see here. New design, by the way. I like the new design. Also, if you're interested in future webinars, you can check out our webinars page, which is at octopus.com/webinars. There you'll find a page that looks like this, and you'll see other webinars listed. I failed to, or I maybe didn't mention this earlier. We also have a YouTube channel. You can find us at /octopusdeploy up on YouTube. A recording of this webinar will be available there. We have other videos as well that we publish. We have a show called Deploy on Friday that we do weekly, sort of catching you up on everything that you need to know about everything and anything related to Octopus Deploy and CD. So make sure to check that out. I mentioned earlier the publications page. You'll find us at /publications, including Liam's awesome white paper, which you can download for free. I'm going to make sure to mention that. And then finally, lastly but not leastly, we also have an integrations page, which you can find at octopus.com/integrations. This is really relevant, obviously, for folks who are utilizing Kubernetes. If you want to find out what we do in terms of that, the steps we have, the community steps we have, also the integration points we have, you can find all of that information at /integrations. Awesome stuff. All right, jumping back to the questions. We've got another question here from Vincent, a follow-up. We can scale up, but sadly stuck on a very large window containers, so it takes a long time to bring a new node in and cache the images and then warm them up.
Yeah. So there's a few strategies you can kind of employ here. Fun fact, when I was in the builds team, or they're now called builds, but the engineering productivity team, we were using Windows containers quite a lot. So I understand your pain. Because we have to build the Windows installer for Octopus Deploy. And we want to do everything in Kubernetes where we can because it's a lot easier. We were doing that in Windows containers. And yeah, Windows containers suck. And to bring them up we're using Azure in particular. The Windows nodes take so much longer to start. They take like 5 to 10 minutes to pop into Kubernetes, whereas Linux nodes come in like 60 or 30 seconds. What we ended up doing is we had a couple of essentially preemptible pods. So to try and keep a spare amount of compute there to act as a buffer, what we had is a whole bunch of kind of throwaway pods that could just pop in. They say, hey, look, I need this amount of CPU. That's what we use as a buffer. And then if anything had to scale up, for example, our actual workload containers, they would pop in and go, I need to be scheduled. I'm more important than this other lowly container here. And it would kick that other container out. That lets you go through and kind of automatically schedule just a little bit of wiggle room while still allowing you to scale up and down really efficiently. That's what ended up being the case for the Windows nodes in particular. The other thing as well, as you mentioned in there, that you have to cache your images to warm them up, especially when you're working with large Windows containers. That makes a lot of sense. There are also plugins for Kubernetes that let you do this automatically. There are ones that essentially go through and you can define what images you're going to use. And as your Windows nodes come up, a daemon set runs in them and makes sure that everything is working. And that all of your images are cached inside the container runtime itself in Windows. So there are a couple of different strategies you can use to try and get yourself that wiggle room that you need, not only for blue-green deployments, which are a little bit easier because you don't mind if it takes 5-10 minutes for them to all spool up for you to start your deployment process, but especially around spikes in usage, that can be really useful.
A good resource to mention also is, coming back, this is a shameless plug on my part. If you come back to our YouTube page, you'll see we have a bunch of videos here. One of the ones that we have available that you might want to check out is this one entitled, How We Use Kubernetes for Octopus Cloud. This one goes into detail about how we actually use Kubernetes ourselves for hosting our own cloud infrastructure, which is for Octopus Cloud itself. So definitely something worth checking out. That's actually from 2 members of the team, Carrie and Pavel, who are part of the cloud team, and they talk extensively about how to do that. Awesome stuff.
Great people.
All right, we got another question. Well. Yes, we got another question here from Thomas. Does it make sense to combine Octopus Deploy with Argo CD, or do you need to choose one or the other? As far as I understand, Argo CD is tightly coupled to GitOps, while Octopus is a different approach.
Yeah, so Argo CD is GitOps, essentially. That's the only way that you can deploy. Octopus deploy is a different approach. It uses pipelines. There's actually some kind of discussion going around about, how Octopus could work with Argo, especially as we kind of work closer with the CodeFresh team and kind of deal with GitOps a lot more. So if you are legitimately curious about that, Nikita, who is the product manager in the team I'm currently in on deployments, would love to talk to you, especially if you're kind of throwing up whether to use Argo CD or Octopus deploy, because you're the exact kind of person that we'd love to talk to about what you see as being useful. The answer to the question, though, is that do you have to choose one or the other? The answer is no. You can have multiple deployment tools, and the different deployment paradigms work in different ways. So GitOps might be really useful for one of your applications, and you might want to use Argo because that's how it works for you. And that's perfectly fine. But there are other times where that might not work. For example, you might already use Octopus Deploy to deploy some of your .NET apps to your Windows servers. Or you might use Octopus Deploy to deploy to things like your AWS Lambda functions or your Azure functions and all of that kind of stuff. And that's something that Argo can't do by default. It's really hard to kind of shoehorn in because some of these systems aren't declarative like Kubernetes is. And that's where a pipeline-based deployment can be very useful. So it's less about whether you choose whether to have them both or not, and whether Argo can actually meet all of your needs. Octopus Deploy is looking at a future where they might be a little bit more integrated. We can do GitOps as well with Octopus Deploy. We have things like Git triggers coming or already here, I believe. And we already have things like config as code, where you can have your entire project defined in code inside of a repo as well. So you can emulate GitOps in Octopus Deploy even currently. So you can use that paradigm if you want.
Awesome. As a follow-up, and we'll get to another question in a second, but Thomas writes, I am curious, yes, since half our company uses Argo CD while I'm on Octopus, I would love to be able to get the best of both worlds, the overview and simplicity of Octopus, and the strict control and auditability of Argo CD, wow, words, and or GitOps.
Yeah, absolutely. That's really good feedback. If you are in our community Slack, if you post anywhere about this, I can guarantee you Kit will find you. But if you can, post in the Kubernetes Slack channel in our community workspace, and we'll reach out and we'll have a chat about what's useful to you.
Yeah, if you go to /community, you'll find a page that looks like this, and you can join our Slack channel very easily there. Another way of doing this is by going to our roadmap, which is at roadmap.octopus.com. Make this a bookmark, if not your homepage. We would really appreciate it. You'll find this here. And you can go ahead and click on this big blue button in the top right-hand corner here and submit your own ideas. So, for example, if I want to support caching for something, or maybe I want to do something else, you can submit these. These go directly to the product team. So make sure to check those out there. But great question. All right, let's get back to some of the other comments here. We have one more question I think we'll have to wrap up from Santos. How do I ensure deployment is successful? Basically, when we execute kubectl apply /f filename.yaml, it doesn't check if the deployment is successful or not. I would like to know if there's any way the command should wait, or if it's successful or failure. I would suggest using a tool. You can use live object status in Octopus, for example. Shameless plug. You can see Liam is laughing there because he knows where I'm getting at. But Liam, you're the presenter. You talk about this.
Yeah, so natively, kubectl apply is simply interacting with the API of Kubernetes. It's just saying, hey, can you please just deploy this file? And it will eventually get there, maybe. Like you say, it doesn't actually check whether the deployment was successful or not. That's where this tooling comes into place. For example, in Octopus, we've got Kubernetes object status, which checks that. In Argo CD, it continuously goes through and applies that and gives you feedback as to whether it's working or not. The answer is different tooling. Don't use kubectl apply -f, your file name, for your deployments. It's useful to test things out with, but it, again, like you're finding, it doesn't check whether it's successful or not.
All right, now we got the trolls showing up. These are members of our team. Nick's asking, how much is your white paper? Chris is saying it's
free.
Yes, exactly. All right, thanks, guys. Really appreciate it. Anyways, if you have additional questions, Liam obviously can be reached. You've got our resources here, so feel free to let us know. And of course, as always, really appreciate your time and attention. Liam, thank you for the great presentation. Go download his white paper. It's free. You'll find it at /publications. Obviously, great to have you, Liam. Thanks a lot. Are you planning a second version of the white paper maybe in a few months' time, or are you working on something else at this moment?
No white papers at the moment. I'm working on a few different things. I'm going to a couple of different KubeCons, so if you're around KubeCon EU, feel free to pop over to our booth. I'll be there. Yes. I'm happy to talk about this or anything else Kubernetes, really.
He'll sign a copy of your white paper if you have it. So there you go.
I will. I did have somebody. Actually come up and ask for a photo and a signed copy. So I did it. It was great.
That's right. No autographs. No autographs. All right. Cool. All right. Thanks a lot, Liam. Really appreciate it. Thank you for your time and attention joining us here at today's webinar. Don't forget to sign up for other webinars. Don't forget to grab Liam's white paper if you haven't done so, and don't forget also to sign up for a free trial of Octopus. We really appreciate your time and attention. And as always, from us to you, happy deployments, everyone. Take care.